So now that you've had a review of proportions, now we're going to talk about similar polygons. And we're going to talk about how we're going to use proportions to talk about the similar polygons. Okay? In the last unit, we did congruent figures, and we talked about that if the triangles were congruent, then all of their corresponding angles and all of their corresponding sides were congruent. Well, in similarity, some things are congruent and some things are not. So here's the deal with similar polygons. Similar polygons, and please make sure you're writing this down, have corresponding angles that are blank and corresponding sides that are blank. Okay? When polygons are similar, whether it's a triangle or rectangles or any other kind of shape, their angles are all going to be congruent. So all of the angles are going to be congruent. And the sides, do you remember in Unit 1 when we talked about dilations? With dilations, the figures looked the same, but they were different shapes. They were the same shape, but they were different sizes. So with similar polygons, the sides are not going to be congruent because you can have one that's small and one that's big, but the sides are going to be proportional. When we did dilations, we talked about that you could have a scale factor of like 3/1 or a scale factor of 1/2, and that would either make the shape bigger or the shape smaller. So similarity is dealing with the dilations that we did in Unit 1. Okay, it's talking about what's the scale factor between the two shapes. So to show you guys an example of this, I want you to draw a quadrilateral, kind of like this. Don't have to look exactly like that. Just draw yourself a quadrilateral, and let's call this KITE. And then I want you to draw one that looks like it, but is smaller. We're going to call this one FLYN. So if I write KITE, and I use this squiggle. Now remember from congruence, what the symbol for congruent was an equal sign with a squiggle over it. Well, now that they're not equal, we're just going to use the squiggle. So that symbol right there means similar. So write that in your notes. So we're going to say kite is similar to FLYN. Kite is similar to flying. All right. So if they're similar, if I'm telling you that they're similar, then that means that all of the corresponding angles are congruent. So do you see how K is in the same place as F? That means angle K is congruent to angle F. And since I is in the same place as L in the similarity statement, that means angle I is congruent to angle L. If T is in the same place as Y, angle T is congruent to angle Y. And if E is in the same place as N, then angle E, and we're going to put 4 arcs in there, is congruent to angle N. So all their corresponding angles are congruent. In addition, their corresponding sides are proportional. So KI is not congruent to FL. These are not the same size, but they are proportional. So to check that piece out, here's what I want you to do. I want you to add 15, 6, 9, and 12 to that shape. On this one, I want you to put 10, 4, 6, and 8. We're going to match up corresponding side lengths, and we're going to check the proportion or the scale factor of each one to see if it checks out. So since KI is the same as FL, KI is 15, FL is 10. When I reduce that, and if you need help reducing fractions on your calculator, come see me and I will help you. But when I reduce that, that reduces to 3/2. So I have a scale factor of 3 over 2 between Ki and FL. So now I need to check to see that all the other corresponding sides have the same scale factor. If they have the same scale factor, that means they're similar. So I'm going to say IT 6 corresponds to LY, which is 4. 6 over 4 also reduces to 3 over 2. TE, which is 9, corresponds with YN, which is 6. 9 over 6 reduces to 3 over 2, and so that one is the same scale factor. And then our last side we have to do is KE, which is 12, and that corresponds with FN, which is 8. Okay, so we matched up 12 and 8, and that reduces to 3 over 2. So do you see how all 4 scale factors reduce to the same thing? And again, if you need help reducing fractions, come see me and I'll show you how to do it very quickly on your calculator. These are all called scale factors. And when shapes are similar, they're going to have the same scale factor. So proportional sides, this is what I want you to write. Proportional sides have the same scale factor. Okay, so if I were to give you a picture of 2 shapes and say, these are similar, find the scale factor, you would look at the sides that go together. So like if I gave you this one, you would put 12 over 8, reduce it, and that would be your scale factor. So that's all you'd have to do. If I gave you these 2 pictures and said, decide if these are similar or not. Well, if they're similar, that means all the sides are going to have the same scale factor. So you check these sides and those and those and those, and if they all have the same scale factor like we have here, then you would say, yes, they're similar. If these were 3 over 2, but then this one over here ended up being like 3 over 4 or something like that, then you would say, no, they're not similar because they don't all have the same scale factor. So before we go on, we're going to talk a lot this unit about similar triangles, but before we talk about that, I want you guys to get used to what it means for any kind of shape to be similar. And it means the angles are congruent and the sides are proportional. So go check your table of contents and see what you're supposed to do next.